Hello everyone, and welcome to another video in my channel. In this video, we are given a quartic equation to solve. We are given x minus 10 in a bracket to power 2 plus x minus 9 in another bracket to power 3 plus x minus 8 in a separate bracket to power 4 is equal to 2. This is a polynomial of degree 4 or a quartic equation. But we are told that x is a member of the set of positive integers, and so we are asked to find the value of x. What many people do in problems like this is that they will begin to expand the brackets. This bracket is especially cumbersome to expand. We have to apply the Pascal's triangle, but it will end up making the process lengthy and even cumbersome. But to avoid expanding this bracket, we need to make a substitution. The substitution is y equals to x minus 8. So we are just going to substitute y for x minus 8 in this part of the equation and then try to expand the others. However, if y equals to x minus 8, then y minus 1 is x minus 9 and y minus 2 is x minus 10. So I have made the substitutions already. So let's begin to expand. So this is relatively easier to expand. So we have y squared minus 4y plus 4 for the expansion, then plus I will apply Pascal's triangle here. That becomes y squared, y cubed rather, because the coefficient is 1, minus 3y squared, then plus 3y to power 1 please, then minus 1 plus y to power 4 is equal to 2. Let me arrange this so that the highest power of the unknown variable will become the first term. So y to power 4 is the first term. Now plus y to power 3, which is this one. Then this and this will be added together, giving us minus 2y squared, because plus y squared minus 3y squared will give us minus 2y squared. Then this and this will now be added together, giving us minus y to power 1. Then this and this will be added, giving us plus 3 is equal to 2. Now, let's bring this 3 to the other side. So I have y to power 4 plus y cubed minus 2y squared minus y is equal to minus 3 plus 2 is minus 1. Minus 1 can be written as minus 1 times 1. It can also be written as 1 times minus 1. But I will have to factorize y out here. If I factorize y out, I have y cubed plus y squared minus 2y minus 1 equals to this, and then y squared, y cubed please, plus y squared minus 2y minus 1 is equal to 1 times minus 1. Now in that case, y equals to minus 1 and y equals to 1, because I'm equating this y to this minus 1 and this y to this 1. Then in the other cases, I will equate these brackets to 1 and this bracket to minus 1. So let us first of all find the value of x when y equals to minus 1. So x minus 8 is minus 1 and x equals to 8 minus 1 is 7. In the second case, x minus 8 is 1, and so x equals to 8 plus 1 is 9. So let us now check if x equals to 7 and x equals to 9 are solutions to the original equation by substituting the values of 7 and 9 for x respectively. So I have 7 minus 10 to power 2 plus 7 minus 9 to power 3 plus 7 minus 8 to power 4 is equal to 2. Now 7 minus 10 is minus 3 squared, and 7 minus 2 is minus 2. 7 minus 9 is minus 2, minus 3 cubed. 7 minus 8 is minus 1 to power 4 equals to 2. Minus 3 to power 2 is 9. Minus 2 to power 3 is minus 8. And we have 1 here because minus 1 to power 4 is 1 equals to 2. Now 9 plus 1 is 10, and 10 minus 8 is 2. So we have a balanced equation. That implies that x equals to 7 is a solution. So we'll put it here. We have a first solution. we need 3 other solutions because this is a polynomial of degree 4. So it will have 4 solution points. Now, to get the other ones, we will do exactly what we did in the first case. So y equals to 1 and we have x equals to minus 9. So let us put in minus 9 for x where we have x in the original equation. Now we have 9 minus 1, 9 minus 10 to power 2 plus 9 minus 9 to power 3 plus 9 minus 8 to power 4 is equal to 2. 9 minus 10 is minus 1 squared, and this is 0. And 9 minus 8 is 1 to power 4 equals to 2. Yes, because 1 plus 1 is 2. So I have another solution point, which is x equals to 9. So x equals to 9 is another solution point. Now we need 2 other solution points. And how can we get them? We can get them by equating this bracket to minus 1 and this bracket to 1. So let us first of all start with this bracket and minus 1. So what I have here is y to power 3 plus y to power 2 minus 2y squared. Minus 2y please minus 1 is equal to minus 1. And so y to power 3 plus y to power 2 minus 2y will now be equal to 0, because when we cross this to this, it becomes minus 1 plus 1, which is 0. I will factorize y out. Y to power 2 plus y minus 2 is equal to 0. And so y equals to 0. Then let's see if we are going to get a solution point when y equals to 0. Let's remember that y equals to x minus 8. And so x minus 8 is equal to 0 and x equals to 8. Let us put in the value of 8 for x in the original equation. The original equation is x minus 10, that is 8 minus 10 raised to power 2 plus 8 minus 9 to power 3 plus 8 minus 8 to power 4 is equal to 2. Now, 8 minus 10 is minus 2 to power 2. 8 minus 9 is minus 1 to power 3. And 8 minus 8 is 0 to power 4, which is still 0. Now, minus 2 to power 2 is 4. Minus 1 to power 3 is minus 1. It is not equal to 2. So, x equals to 8 is not a solution. So, we'll reject this part. Also, let us try y squared plus y minus 2 is equal to 0. We can factorize this. So we have y squared plus 2y minus y minus 2 is equal to 0. If we group them, in the first bracket, y is common, y plus 2. In the second one, minus 1 is common, y plus 2 equals to 0. So y plus 2 and y minus 1 is equal to 0. And y equals to minus 2 please, or y equals to 1. When y equals to 1, we have a solution point, which is x equals to minus 9. So we are not going to try this, but let's try this. So x minus 8 equals to minus 2. And so x equals to 8 minus 2 is 6. Let's now put in the value of 6 for x in the original equation. So I have 6 minus 10 squared plus 6 minus 9 cubed plus 6 minus 8 to power 4 equals to 2. 6 minus 10 is minus 4 squared. 6 minus 9 is minus 3 cubed. 6 minus 8 is minus 2 to power 4 equals to 2. Minus 4 squared is 16. Minus 3 cubed is minus 27. And minus 2 to power 4 is 16. It is not equals to 2. So x equals to 6 is not a solution. Therefore, we'll reject this solution. Now, the last step is for us to equate y to power 3 plus y to power 2 minus 2y minus 1 is equal to 1. So I'll move this one to this side. I have y to power 3 plus y to power 2 minus 2y minus equals to, rather, when I move this minus 1 to this side, I'll have plus 2. So I have 2 here. Now let us factorize. If I factorize y out, I have y squared plus y minus 2 is equal to 2 times 1. So y equals to 2 in this case, or y equals to 1. We have a solution point here. Then y squared minus y plus y minus 2 is equal to 2, or y squared plus y minus 2 is equal to 1. We're going to try this and these two cases. So for this case, when y equals to 2, x minus 8 is equal to 2, and x equals to 8 plus 2 is 10. So let us put in the value of 10 for x in the original equation. So 10 minus 10 squared plus 10 minus 9 squared cube, rather, plus 10 minus 8 to power 4 is equal to 2. This is 0, and this is 1 cube, which is 1. 10 minus 8 is 2, and 2 to power 4 is 16. It is not equal to 2. Therefore, this is also not a solution. Already we have tried this. So let us now try for these two sets. So when y squared plus y minus 2 equals to 2, we have y squared plus y equals to 4, or y squared plus y minus 4 is equal to 0. We can't factorize this, and the discriminant of this equation is 17, because b squared minus 4 times a times c will give us 1 squared, because b is 1 here. 1 squared minus 4 times 1, which is 4, times minus 4, which is now 16. So I have plus 17 here. And we are told that x is a member of the set of positive integers. So all the solution points from this factor will give us no solution. Now, lastly, let us try when y squared plus y minus 2 is equal to 1. So y squared plus y minus 2 is equal to 1. And so we have y squared plus y is equal to 3. Because when we move this here, we have plus 2. Plus 2 and 1 will give us 3. So I have minus 3 here equals to 0. Again, the discriminant b squared minus 4ac will give us plus 13, which will not yield a positive integer. Therefore, the solutions to this equation, provided that x is a member of the set of integers, is x equals to 7 and x equals to 9, which are positive integers, as we can see, as the condition gives us. Please like this video, subscribe to my channel if you haven't done so, and also share this video. Thank you very much for watching.